their solutions and also some theoretical concept related to the topic frictional force. And this lesson is beneficial for NEB plus 2 science entrance examination and other scholarship exam like PCL nursing, pharmacy. Today's first MCQ is, if limiting friction is F and normal reaction is R, which of the following represents the coefficient of friction? Okay, here if the limiting friction is F and normal reaction is R, which of the following represents the coefficient of friction? Option A, F into R, option B, R by F, option C, F by R, and option D, none of the above. Okay, before doing these questions, we must know some concept about frictional force, because this question is related to the topic frictional force. Here limiting friction, normal reaction, so we should know what is the limiting friction, what is the normal reaction, what is the coefficient of friction. And so to understand this, I want to turn your mind toward the theoretical background related to the frictional force. Okay, frictional force, the force generated by the two surfaces that contact and slide against each other. Okay, it is self-adjusted. And exists in opposite direction to the applied external force. This frictional force is opposing force. Okay, this is an opposing force which is acted opposite to the direction of applied force to place a body sliding on the surface in equilibrium. Okay, this force which always act opposite to the direction of motion is called frictional force, and this force is self-adjusted force, and this exists between two surfaces that are in contact. Okay, here to understand this frictional force, I introduce here some graphical figure, and this figure surely understand what will be the frictional force. Okay, now discuss it. And I place this box on this sliding surface. This is horizontal surface, and this box has weight mg, and this mg is balanced by normal reaction. Okay, this R is normal reaction. To balance, to be in equilibrium position, to be placed on a certain surface, there must be equal and opposite force should be added so that the body can situated equilibriumly on the surface. So in this situation, this mg is weight is balanced by this normal reaction R, and this F is the external applied force. This external applied force F is applied toward the direction to pull this box sliding on the surface, and when we apply this force on this body, the body is pulling toward this direction. At the same time, there is the force between the two surfaces, this box surface and this plane surface is developed, which oppose this motion of the box toward this external applied force direction is called frictional force. This always oppose the direction of motion, and which helps the body to be in stable position. That means stable position, and so the box does not fail on the surface. Okay, and it just remain as it is in the original way, and it moves to this direction. This friction force keeps this body from falling into the surface. Okay, now this friction force is the always opposing force to the motion of the boxes. Okay, now next go static frictional force. What is the static frictional force? Frictional force existing on a body at rest. Okay, we can easily remember that this static means when it is in rest. Static means in the state of rest. We understand that by the name of static, this frictional force is developed when these boxes, for example, when this boxes is placed on the surface, when the force is just try to keep in motion this box, and in this situation, in motion, in this situation there is frictional force. In already also there is friction force, totally frictional force, and when just try to move, there is also some frictional force. Then this frictional force is called as static frictional force. And when this box is in motion, and in this situation there is also friction force developed to oppose the motion of box between the two surface of box and this plane. This is called kinetic frictional force. This kinetic friction force existing on the body in motion. Okay, this kinetic friction force are two types. They are categorized as two types because this body may slide on the surface, or this body may rotate or rolling on the surface. If the spherical body or if the cylindrical body is present, then they are always sliding as well as rotating on a surface. Okay, but if this kind of body is present, it may be only sliding also. Therefore there are two types of friction is occur. One is sliding friction. This friction exists when a body slide on the surface. When the body is slide on the surface, for example, I introduce a inclined plane here. Here is angle theta. When the cylindrical spherical ball is placed here, this ball is rolling on that plane to reach the ground level. Therefore in this situation there is opposite force, frictional force is created to the direction of motion, opposite direction of motion. So this friction force is called rolling frictional force. When this ball is rolling down or rotating down, then the friction force which develop to oppose the motion of this ball is called a rolling frictional force. Okay, if this ball is sliding, this ball is with sliding as well as there is rolling also. If the ball is sliding, there is also certain friction force which develop during the sliding situation, and this friction force is called the sliding frictional force. Okay, limiting friction. What is the limiting friction? Limiting means any value have their limiting value, that is highest top of value. This highest top of value is equal to maximum static frictional force. It is also very important, and it is asked several or multiple times in tax examination. Okay, this is very important. Normal reaction. What is the normal reaction? It exists normal to the surface. It exists normal to the surface and opposite to the weight of the body. Here I already discussed that this R is called normal reaction, which always balance the weight of the body to place this box in stable position. No stable. It is also in motion position, but it by the help of this R and mg, it could not fall down on the surface. Okay. And another relation F equal to mu r. When we discuss this frictional force and normal reaction, the relationship between this frictional force and normal reaction is directly proportional to normal reaction. Frictional force is also developed as a directly proportional to the R. F is directly proportional to the R. Okay. Okay. Directly proportional to R. When F is directly proportional to R, this to remove this direct proportional sign, the constant is appear, which is called mu, and this mu is a coefficient of friction. This coefficient of friction equal to this frictional force upon normal reaction. Okay. Next, go to the another slide. Here, you had one of the relation here. Sorry. Okay, there is. Okay, here is one relation, mu r is greater than mu k greater than mu, where mu r is a coefficient of rolling friction, mu k is a coefficient of kinetic friction, and mu is a coefficient of static friction. Okay, this is the relation, and it is very important and asked several times. Okay, this is very important question for NEB +2 in task examination. This is maximally asked. Okay, here mu r is rolling friction, mu k is kinetic friction. Kinetic friction is two types, one is sliding friction and another is rolling friction. These two type of sum is equal to kinetic friction, and we also remember that this rolling friction is must be less than kinetic friction, and this must be less than the static friction. You should remember this relation between rolling friction, kinetic friction and static friction. Now next go. Mu equal to tan theta, where theta is the angle of friction, theta is the angle of friction, and is defined as the angle made by the resultant of normal reaction and the limiting frictional force. Okay, this mu equal to tan theta is the relation between the coefficient of friction, this mu, and theta is the angle of friction. Coefficient of friction equal to tangent to the angle of friction, and this definition is can be easily understood by understanding this figure. Okay, and this figure is the representation of angle of friction theta, and which is the angle between this limiting friction of force and resultant of normal reaction. This is resultant of normal reaction, and when we solving this, we got this mu equal to tan theta. Now next, mu equal to tan alpha, where alpha is the angle of repose and is defined as the angle of inclination. Alpha is the angle of repose and is defined as the angle of inclination of an inclined plane with a horizontal when a body resting on a plane surface just slide down. Okay, this means this angle of repose can be easily understood by seeing this figure. Here this alpha is a angle of repose when this alpha is called angle of repose when this body kept on this inclined plane just sufficient to slide on the surface. In this situation, the angle between this inclined plane and this horizontal surface is called angle of repose. Okay, next go to another point. The coefficient of static friction, and coefficient of kinetic friction depend on nature of the substance, nature of surface in contact. Okay, this coefficient of static friction and coefficient of kinetic friction depend on the nature of surface in contact. Means it only depends on the nature between the two surfaces which are in contact. And this limiting friction force, is called maximum of static friction force, which depends on the direction of applied force as well as nature of the surface. That means limiting friction force depends on two factors. One is applied force and another is nature of surface. Okay, next go to the today's MCQs. Question number 1. We already discussed this question, and this question is a relationship between limiting friction force, normal reaction, and coefficient of friction. And when you discussed some theoretical concept, we got that this coefficient of friction related to this limiting friction and normal reaction is this F equal to mu r. This is already discussed in theoretical concept. Okay, when you see this mu equal to F by R. Okay, and option C, in option C there is F by R, so option C answer is the answer. Sorry. Question number 2. A body of mass 10 kg, is raised to a height here of 8 meter. Work done is option A, option B, option C, and option D. A body of mass 10 kg is raised. Our work is to raised this height of 8 meter. Okay, height to 8 meter. This body is raised to height of 8 meter. During this time, some work done is necessary to raise this body. Okay, so when the body is here in this condition, when we raise this body on that places, there is height earth. In that condition, we should have done certain work to raise this body and from that position to at that position. So we think that there is a raising up to the height here. Therefore, the work done required should be equal to the potential energy of the body when at this position. Therefore, the work done is given by potential energy of the body, potential energy developed on a body. Okay, MGS. Okay, this is work done. This is will be MGS. This is also equal to work done. When we put the mass m, value of mass m 10 kg, g 9.8 and h equal to 8 meter, we can get the value which is equal to option V. M 10 into 8, 80 into 9.8, 80 into 10, 800, 80 into 9.8, nearly 800, which is the nearly 800. Option V will be answer. Okay, next go to the another question. Question number 3. If a momentum of a body is double, if the momentum of a body is double, the factor by which kinetic energy increase. Option A, option B, option C, and option D. Here, if a momentum of a body is double, the condition is momentum of a body is double. We have to determine by what factor the kinetic energy is increased. Okay, this is the question relation to the momentum and kinetic energy. And we know that the relationship between the kinetic energy and momentum, that this kinetic energy equal to p square by 2sm. This is also discussed in previous lecture. Okay, and this kinetic energy equal to p square by 2sm. When in our questions there is momentum is double, momentum is double, this momentum is double, this momentum is double, so p equal to must be equal to twice p. When you put this twice p in this value, this p value, and we got this 4 p square by twice of this is kinetic energy, 4 times kinetic energy. When the momentum of a body is double, the kinetic energy is increased by the factor 4. Okay, by factor 4. Option is, answer is option C. Okay, next question number 4. The maximum value of static friction is called. Maximum value of static friction is called a frictional force by B, limiting friction, C, maximum friction, none of the above. We already discussed that the maximum value of static friction is called limiting friction. Okay, which is already discussed. Okay, option is answer is option number B. Okay. Okay, next question. Question number 5. The coefficient of friction for a given pair of surface. Coefficient of friction for a given pair of surface. We know that this coefficient of friction mu. Okay. For a given pair of surface is equal to option A, sine of angle of friction, option B, cosine of angle of friction, tangent to the angle of friction, octane of angle of friction. Means this option are related to the angle of friction. We see that already, we discussed already that the coefficient of friction is equal to tan theta. Okay, we already discussed where theta is the angle of friction. Also we discussed already that mu equal to tan alpha. Alpha is the angle of repose. But in this question, this is the angle of theta friction. So it is a tangent to the angle of friction, which will be the answer. Option C, in with the tangent to the angle of friction. Okay, option C is correct. Question number 6. The static friction is. This static friction. What is the static friction? The friction or force which develop in a state of rest. Okay, between rest to one sliding surface and another is sliding body. Okay, when they are in rest condition. Always greater than dynamic friction. This is also true. Always less than dynamic friction. This is false. We already discussed. Equal dynamic friction. This is also false. Depending on surface and contact. This is also true, and this is also true. But when you choose this one of them, the answer should be chosen as always greater than the dynamic friction. If both A and D is given, then we should select A and D. Okay. Both A and D, but in this situation we must choose option A. Okay, here I mentioned some theoretical concept related to the centripetal force, centripetal acceleration, in which a body is rotating with angular velocity omega around the circular path with uniform velocity u, and this is the figure. When we see this figure, when you see this figure, this acceleration are always directed toward the center at every point, at any point of the circle, okay, and this velocity is directed in different direction. At that position, this is directed toward the motion of the body, and which is tangent to the motion of the body, and in that point it's directed toward the this direction, and this direction toward the south direction, and this direction east direction. So the velocity, even the velocity is same, their direction is different, but acceleration is same. Acceleration is constant and it is directed toward the center. It's always directed toward the center, and this is a uniform motion. This is a condition of uniform motion. I mentioned some here. The velocity v and acceleration a in uniform circular motion at angle of omega rate omega, that rate means velocity. The speed is constant, but the velocity is always tangent to the orbit. This velocity is tangent to the orbit. The acceleration has constant magnitude, this acceleration has constant magnitude, but always point toward the center of the rotation. This always point toward the center of the rotation, toward the center. And when we do some mathematical process, we can calculate that velocity equal to omega r. Omega is angular rate or angular velocity, and r is the radius of this circular orbit. And acceleration due to acceleration is equal to v square by r. This acceleration also called as centripetal acceleration, which is equal to v square by r, and this force also called as centripetal force, which is equal to mv square by r. It is from force equal to m into v square by r equal to mv square by r. Okay. Next, question number 7. For a body rotating uniformly in a circular path, which of the following is true? Since the body is rotating uniformly in a circular path, okay, the body is rotating uniformly in a circular path, which of the following is true? This, the theoretical concept related to this rotating uniformly case, I discussed already in that slide, and this question is related to this theory. Which of the following is true? Option A, it has same speed at all points. Option B, it has same velocity at all point. It has same momentum at all point. All of the above. We know that this it has same speed at all point. Okay, this uniform circular motion, it has same speed at all point. This is correct answer. It has same velocity. No, it has same velocity with different direction. It has same momentum. No, this momentum equal to m into v. So this is also not correct. Answer is A. The weight of the body maximum. Okay, the weight of the body is maximum. Option A, at the top of the mountain, at the sea level, at the center of the earth, inside the deep mine. Which will be the answer? Okay, we know that weight equal to mg. Weight equal to mg. We easily can say that this m is mass. Mass is a always constant quantity, and to be this weight maximum greater, this g is must be greater. At which place this g is maximum, in that place the weight also maximum. Now go to discuss at the top of the mountain. At the top of the mountain, when you go to the top of the mountain, that is at the height from the sea level, the gravity is goes on decreases to that of the sea level. Therefore, this g is less than the gravity at the top of the mountain is less than the sea level. Therefore, weight is less than the sea level. At the sea level, g, obviously g. When you comparing this A and B, we can say that at the sea level weight is greater than the top of the mountain. When you go to this option C, at the center of the earth, we know that at the center of the earth the resultant gravity is 0 and total weight is 0. At this condition, weight is 0. Inside the deep mine, when you go to deep mine, that is depth, the g also decreases to that of the sea level. Therefore, we can easily say that the option B is correct, in which weight of the body is maximum to the rest places. Okay, today lesson is finished. If you think this video is beneficial, you can like, subscribe my channel to upgrade with a new video. Thank you everyone.